The basic function of all heat exchangers is to heat or cool fluids. But even though they all do the same basic job, they're often designed differently. For example, the shells and tubes of heat exchangers are often designed to create certain flow paths. These flow paths determine the number of times the fluids pass by each other and the direction or type of flow through the heat exchanger. This shell and tube heat exchanger can be described as a single pass unit. The fluid on the tube side enters one head and exits from the other head. The shell side fluid enters here, flows in the opposite direction, and exits here. The two fluids pass each other only once. This heat exchanger is designed so that the tube side fluid passes the shell side fluid twice. The tube side fluid enters here and is directed through half of the tubes by the inlet head. After passing through the first half of the tubes, the fluid is directed into the rest of the tubes by the return head. The fluid then passes through the rest of the tubes and is directed out of the heat exchanger. Besides the number of passes, the flow paths inside a heat exchanger can also be used to categorize types of heat exchangers. There are three general categories for the flow path through a heat exchanger: parallel flow, cross flow, and counterflow. In a parallel flow heat exchanger, the shell side fluid and the tube side fluid move in the same direction. In this heat exchanger, the tube side fluid passes through the tubes in this direction, and the shell side fluid passes around the tubes in the same direction. In a cross-flow heat exchanger, the fluids flow perpendicular to each other. The tube side fluid enters through this inlet, flows through the tubes, and exits through this outlet. The shell side fluid enters the shell through this inlet, flows across the tubes, and leaves the shell through this outlet. In a counterflow heat exchanger, the fluids move through the shell and tubes in opposite directions. During operation, the tube side fluid enters this inlet, passes through the tubes, and leaves the unit through this outlet. On the other side of the heat exchanger, the shell side fluid enters this inlet, flows around the tubes, and leaves the unit through this outlet. With parallel flow heat exchangers, the temperature difference between the two fluids is greatest where the two fluids enter the heat exchanger, so the amount of heat transfer is greatest at this point. By the time the fluids are near the outlets, there is little or no temperature difference, so little or no heat is transferred. Counterflow is often the most efficient of the three types of flow, because the temperature difference between the two fluids remains relatively constant as the fluids pass side by side. As a result, heat transfer between the fluids can take place the entire time that they're in the heat exchanger. When the temperature difference between the two fluids in a heat exchanger that uses cross-flow is plotted on a graph, it appears to be very similar to the graph for a counterflow unit. Cross-flow units are often used to condense process vapors. In this topic, we talked about shell and tube heat exchangers. We looked at the basic parts that make up this type of heat exchanger, and we described different ways that fluids can flow through them. Like all other heat exchangers, a plate heat exchanger transfers heat from one fluid to another. This particular plate heat exchanger uses a series of thin metal plates placed back to back to transfer the heat. The plates are arranged so that hot fluid flows downward on one side of a plate, and cold fluid flows upward on the opposite side of the plate. The heat is transferred from the hot fluid through the plate to the cooler fluid on the other side of the plate. To see how a plate heat exchanger works, we'll use this simplified illustration of a counterflow plate heat exchanger. If we look at a few of the individual plates, we can see that during operation, the hot fluid enters this inlet, flows through the portholes, and passes downward between the plates. The fluid then flows into the portholes at the bottom of the plates, where it's directed to the hot fluid outlet. The cold fluid enters the heat exchanger on the bottom and passes through another set of portholes at the bottom of the plates. The cold fluid then flows upward on the opposite sides of the plates and exits the portholes at the top of the plates. From there, it's directed to the cold fluid outlet. Keep in mind that the plates are actually back to back, so the two fluids pass each other on opposite sides of a plate, moving in opposite directions. All plate heat exchangers work basically the same way, so by looking at the components of a typical plate heat exchanger, you'll better understand how all plate heat exchangers work. This plate heat exchanger consists of a series of thin metal plates and two fixed end plates. The end plates are used to help support the other plates, and they hold the fluid inlets and outlets. The plates inside the heat exchanger have a corrugated or ridged surface. The ridges cause turbulence as the fluid passes over the plate. The turbulence helps increase the amount of heat that's transferred. The plate also has portholes. These portholes direct the flow of fluid between the plates. Near the portholes are flow directors that distribute the fluid evenly over the plates. Between each two plates is a gasket which separates the plates and creates a channel between them. The gaskets also seal the plates together so that the process fluids won't leak out of the heat exchanger. The gaskets also seal around the portholes so that the two fluids won't mix together and contaminate each other. In this topic, we focused on one type of heat exchanger commonly found in plants, a plate heat exchanger. We looked at the parts that make up a plate heat exchanger, and we saw how the unit operates.